In the previous video, we talked about triglycerides, and these were compounds that were built on a glycerol backbone. And so we had CH2, CH, CH2, right? And glycerol has 3 alcohol groups, and these alcohol groups each get condensed with a fatty acid. So we end up with this molecule that has 3 ester linkages attached to fatty acid chains. Right, so we can see in this compound we have this region here that's all nonpolar, right? All our fatty acid chains are all nonpolar. Up on this end, we also have a nonpolar region of this compound. So there's really no polar region of triglycerides. Okay, that's important in noting that these are not going to be part of biological membranes. These are the form of fatty acids that get stored for future energy production. Okay, so they get stored in fat tissue. When fatty acids get incorporated into lipid bilayers, we talked about how they make these phospholipid structures that then combine together, right? And when they combine together, they can form our lipid bilayers. They group together with the fatty acid tails, or our hydrocarbon chains, clump together in the core, and then on the outside, exposed to water, are our polar head groups. So what we're going to think about in this video is how these individual phospholipids form, right? How we go from 2 fatty acids into this compound that has a polar head group with 2 fatty acids attached to it. And the great thing is that the structure of it is really, really similar to our triglycerides. The only difference is that we do not have 3 fatty acids on glycerol. Instead, we just have 2. Okay, so let's go ahead and redraw our glycerol backbone here. Okay, so we have CH2, CH, and CH2. We have our 3 alcohols, and these first 2 get condensed with a fatty acid. And we'll talk about this more a little bit later, but this first fatty acid is always saturated. The second one is always unsaturated. Okay, and that's a really important feature of lipid bilayers because it makes sure that there's a mixture of saturated and unsaturated fatty acids, allowing the lipid bilayer to be fluid. Okay, so then on this third alcohol, in this position right here is where our polar head group goes. So our polar head group is always attached through a phosphate. So I have a phosphate here, and then attached to another molecule. And for our purposes, this is always going to be serine or choline. Okay, so serine is an amino acid that we'll see more of later in the term, but it has the structure that looks like this. So if our polar head group is serine, then this whole compound gets attached to the phosphate through this oxygen right here. So this oxygen is replaced by this oxygen. So we would then have this compound as our polar head group. So you see that we have a positive charge and we have a negative charge, making this easily able to interact with water. The other common polar head group that we're going to see is choline. And choline looks kind of like serine. We have an alcohol with 2 carbons, but now we're attached to a nitrogen with 3 more carbons around it. So we have a permanent positive charge. So if choline is our polar head group, then this oxygen goes here just like we saw with serine. Okay, so let's go ahead and finish this video up by learning how to draw these phospholipids. Okay, so our goal is to draw phosphatidylcholine. that's made with 16,0 and 18,2 and -3. Okay, so let's go through these pieces first. So phosphatidylcholine. So this is the common name of a phospholipid that's made with the polar head group choline. If the polar head group happened to be serine, it would be called phosphatidylserine. The phosphatidyl part tells you that it's a phospholipid. Okay? We know that the choline is going to take up one position of our glycerol backbone, and our saturated fatty acid will take up one position, and our unsaturated fatty acid will take up the other position. Okay? And a really easy way of remembering the order is it's always sup. Saturated, unsaturated, phosphate. Okay, so we always have the unsaturated fatty acid in the middle. Okay, so let's go ahead and try this. So on our glycerol backbone, on the first carbon we have our saturated fatty acid, and this is the one that's 16 carbons long. So this is a 16 carbon fatty acid that's saturated. That goes on our first carbon in glycerol. On the second carbon is where we put our unsaturated fatty acid. Okay, so this is a two double bonds, the first one on the third carbon away from the end of the carbon chain. All right, so let's try drawing this. Okay, so drawing these unsaturated fatty acids from the carboxylic acid, it takes a little bit of practice. Let's verify that we drew it correctly, because we need to make sure that we have 18 carbons, and the first double bond is 3 carbons away from the omega terminus. So this is position 1. Okay, so our 2 double bonds are at the right position, but let's make sure we have 18 carbons. So it looks like we're in good shape. If you need to draw out the fatty acid by itself before linking it up with the glycerol, that's okay. Go ahead and do that. And then you can see what it should look like, and then you can draw it. All right, but we can finish up our phosphatidylcholine by drawing in the phosphate on the third carbon. And linked up to the phosphate is choline. So there's our polar head group. So this compound is phosphatidylcholine. It'll interact with the lipid bilayer with this whole part of it being the polar head group, so it'll be oriented towards water, right? So this is where our choline is. And then our 2 fatty acid chains we can see here. The one thing that's really important to note here is that our middle fatty acid chain has double bonds, so it would actually be kinked. Okay, so the way that these situate themselves into the lipid bilayer is with one saturated and one unsaturated fatty acid.